Okay, so today we're going to do lesson 5.5 notes, but before we do that, I want to give you some background on the Pythagorean theorem. So you guys have this sheet of notes that I gave you yesterday. The objective for this is to find the square roots of variable expressions and then to use them to solve equations and problems. So the Pythagorean theorem basically says that in any right triangle, okay, so a right triangle means that these, let me fix my pen, that one of the corners has to make a right angle, a 90-degree angle. So in any right triangle, the square of the length of the hypotenuse, this is the hypotenuse, the longest side, equals the sum of the squares of the other two sides. So we write that as c squared, being the hypotenuse, is equal to a squared plus b squared, the other two sides. Okay? So just to show you where this comes from, here's a proof of the Pythagorean theorem. So we know that this big square here has a length of its side equal to a plus b, right? So if the length of the side is equal to a plus b, how would you find the area of the square? Well, the area of that big square is going to be equal to the side times the side. So we're going to have a plus b times a plus b. Okay. Now, we know that this area of this giant square is going to be equal to all these little areas added together. So we've got this triangle, this triangle, this triangle, and this triangle, all those added together, plus this other little square on the inside. That should equal the area of the whole big thing, okay? So let's look at first the smaller little square inside. That smaller square, the area is going to be equal to c squared because one of its lengths is c. So to find area, we multiply the side times the side. So for the triangles, one of those triangles, okay, for one of those triangles, it's going to be equal to 1/2 a times b because the area of a triangle is 1/2 the base times the height. Okay, so the height is b and the base is a. So if one of them has the area of 1/2 a times b, we know that we need the area of all four of them. So that means we need to multiply that area times 4 to get the area of all of them together. When we multiply that together, we're left with 2ab. Okay, so all added together, the area of the four little triangles, 2ab, plus the area of the little square, that area we said has to be equal to the area of the whole big thing, which was a plus b times a plus b. Okay? So I'm going to keep going. All right. If we carry this out, we're going to get 2ab plus c squared equals. You guys we haven't done this yet, but this is called foiling, and we're going to get a squared plus 2ab plus b squared. And now we're going to combine like terms on both sides. If you notice, there's the same term on both sides, so those can cancel. And we're left with c squared equals a squared plus b squared. And that's what we said at the very beginning is what the Pythagorean theorem is equal to. The length of the hypotenuse squared is equal to the length of this other side of the triangle squared plus the other side of the triangle squared. Now, you guys might not have known this yet, but if I wanted to just have the length c of the side, the way we do that is we take the square root. So I don't know if you guys have seen this yet, but if I want to take this, I have to take the square root of c squared to get just a c. So if you take the square root of something squared, you'll be left with just the base. So we're going to be left with a squared plus b squared, and we have to put that new radical in, okay? And note, c is always the longest side of the triangle, okay? So I'm going to go on to the back. So we're going to try some examples here. Okay, so they give us A and B, but we have to find c. So our Pythagorean theorem says a squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared. 6 times 6 is 36. 8 times 8 is 64. That's equal to c squared. When you add those together, you get 100 equals c squared. But I just want the length c. So the way we solve for c is we take the square root. If we take the square root of one side, we have to do that to the other side. What is the square root of 100? Well, what do we have to multiply by itself? What do we square itself to get 100? Well, the answer is 10. 10 times 10 is 100. So your length in that case is 10. Okay, for this next one, we don't know a, so we're going to have a squared plus 9 squared equals 11 squared. A squared plus 81 squared, or 81 equals 121. We're going to subtract 81 from both sides and get a squared equals 40. Now, I just want a. You have to take the square root. So a is equal to the square root of 40. Okay, now those of you who don't remember your radicals, we can separate that into radical 4 times radical 10. And if you remember, the square root of 4 is 2, so we can rewrite that as 2 times radical 10. That is the length of your a. All right, we're going to try one more. So 10 squared plus 10 squared is equal to c squared. So that's going to be 100 plus 100 equals c squared. 200 equals c squared. I have to take the square root of both sides. So I get 200 is square root of 200 is equal to c. Now we can separate 200 into radical 100 times radical 2. The square root of 100 is 10, and we have to keep that 2 with it. So our answer is 10 radical 2. Okay? One last example here. They want us to find the length of a diagonal of a rectangle. So we have a rectangle here. It has a side whose length is 12 and a side whose length is 6. And they want to know what's the distance of this length right here, the diagonal. Well, if you think about it, this is like one side of your triangle, this is the other side of your triangle, and this is your C. So 6 squared plus 12 squared is equal to C squared. 36 plus 144, this is where you really have to know your squares, is equal to C squared. When we add those together, we get 180. Now we have to take the square root of both sides. So the square root of 180 is equal to C. You can simplify 180 into radical 36 times radical 5. The square root of 36 is 6 times radical 5 is equal to C. So if you guys are not sure on your square root rules, you really want to double check those. Okay, so now we're going to look at our distance, midpoint, and distance formula. So for our warm-up, we're going to actually carry these out. So 6 minus 10 comes to a negative 4 squared. That'll equal positive 16. And I think you guys have these answers on your sheet, so sorry about that. I just want to show you how to do them. Negative 1 minus 5 comes to negative 6. When we square that, we get a positive 36. Okay, on these next ones, these aren't perfect squares, but we know that the square root of 81 is 9. So the square root of 84 is going to be 9 point something. At least you could guess that. And on your sheet, I think it says 9.2. For the next one, the next closest perfect square is 36. So our answer is going to be 6 point something. That's the closest we can get, and it's actually 6.1 when we take the square root. Okay, so we're going to look at using the distance formula to find the distance between points, and the Pythagorean theorem is going to come into play. We can use coordinates to find the distance between 2 points or the length of a line segment. To find the length of the line segment in this drawing, so they're showing you the line segment PQ. To find that length, we draw a horizontal segment from P to Q. We use the Pythagorean theorem because we know that the one side, that side squared plus this side squared. Hold on, I lost my little drawing thing. Okay. So B squared plus A squared will give me C squared. That's what we just did on our Pythagorean theorem. When you solve for C, you take the square roots of both sides, so it's going to be the square root of A squared plus B squared. And then finally, when we plug that into our formula, the length A is actually the difference of your X values because it runs horizontally. X runs horizontally, so it's your X2 minus your X1. And then the distance of your B is actually just the distance between your Y values since it runs up and down. So that's why it's Y squared or Y2 minus Y1. So this is our formula we're going to use to actually find the distance. So the Pythagorean theorem states that if we have a right triangle, the lengths of its side, A and B, and the hypotenuse, C, we can use those to find the length of hypotenuse, A squared plus B squared equals C squared. So the distance formula is equal to the square root of the x2 minus x1, so the second x value minus the first x value squared, plus the second y value minus the first y value squared. But you have to have 2 points to do this. So we're going to try this. They give us 2 points. The first point is -2, -1, and the second point is 4, 3. So to find the distance, we have our formula, and we're just going to plug things in. So we're going to take x, our second x point, 4, minus our first x point, so minus a -2 squared, plus our second y value, 3, minus our first y value, minus a -2 squared. Now be careful, because on our slope formula, remember we did y first, y2 minus y1 over x2 minus x1. This is different. We start with our x, okay? Now we're going to simplify. Well, 4 minus a -2 is actually like 4 plus 2, so that becomes 6 squared, plus a 3 minus a -2 is like, becomes 3 plus 2, so that is 5. Now we're going to square that. 6 times 6 is 36, plus 5 times 5 is 25. When you add what's together under the radical, you get 61, and you can actually just leave your answer like that. So the distance of this line is the square root of 61. I don't want you to have to worry about doing that on your calculator right now, or we're not going to do it on our calculator, but if you wanted to know, that actually comes out to about 7.8, but you can just leave it in the radical form. Okay, so we're going to try another one. They give us 2 points, and we can actually solve for the length of these lines to find the distance. Since it's a drawing, this makes life a little easier. You can look. This length of the triangle goes from here over at -2 all the way over to +4, so that's a distance of 6 units. And then this distance right here, this is going from a y value of 3 all the way down to a y value of -2, so that distance is 5. So now we have to solve for c, so we're going to do 6 squared plus 5 squared equals c squared. 6 times 6 is 36, plus 5 times 5 is 25. When we add those together, we are going to get the square root of 61 again. Or sorry, I just did this in one step. I wanted to take this. So our distance, they're just showing you now with the Pythagorean theorem, is the same thing, radical 61. So it's the same as the last problem. It's just when you have a graph, it's a little bit easier because you can just look at where the points are. Okay, so a couple more examples. We're almost done. So we're going to use the distance formula first, and then we're going to use the Pythagorean theorem to make sure we're right. So we have our points 3, 2, -3, -1. We're going to plug in our second x value, which is -3, minus our first x value, 3, plus our second y value, -1, minus our first y value, which is 2. If you guys get confused, you could write above here, like this is your x2, y2, x1, y1. Okay, so -3 minus a -3 is a -6 squared, plus -1, -2 is a -3. I forgot a little square there, squared. So we're doing everything under the radical first, you guys, so make sure you're aware of that. So a negative times a negative is a positive 36. A -3 times a -3 is 9. And that is going to give us, where am I? That is going to give us the square root of 45. If you wanted to simplify that, 45 we know can be broken down into 9 and 5, which is, when we take the square root of 9, that's just 3. So if you wanted to write it in most simplified radical form, you could do it like that. So we're going to look at the same example now, just using the Pythagorean theorem. So the distance of this right here is 1, 2, 3, 4, 5, 6. The distance right here is 3. So we're going to use 6 squared plus 3 squared equals c squared. That's the side we're trying to find, the length between the points. 36 plus 9 is equal to c squared. 36 plus 9, again, comes out to 45. And then I'm going to take the square root of it, of both sides. So 45 is equal, square root of 45 is equal to c. Again, we could break that down into radical 9 times radical 5, which simplifies to 3 times radical 5. Okay? So they're just showing you the distance formula and the Pythagorean theorem are going to give you the same answer. All right, one more. We have a word problem. Each unit on the map represents 100 meters, okay? How far is it from the roller coaster, so from this point, to the Ferris wheel, to this point? That wasn't a very straight line. So we're going to plug in our values. I'm going to use this as my x2, y2, and this is my x1, y1, okay? So my x2 is, what do I have? I've got a 6 minus a 2 plus my second y is a 2 minus 8. So that's going to give me radical, what am I going to get? 4 squared plus 2 minus 8 is going to be a negative 6 squared, but when we square everything, they're going to be positive. Now we're left with 16 plus 36, which gives us the square root of 52, okay? If you were to plug that in your calculator, that comes out to about 7.2, but they told us that every unit represents 100 meters, so this is only 7.2 units, so we actually have to multiply it by 100 to get about 720 meters is the real distance, like if you were out in the park, okay, not just 7.2. This is just a scale, kind of like when you're looking at a map, okay. And then our last example, just solving for your Pythagorean theorem again. So we want to know the missing link. So we know that a squared plus b squared is equal to c squared. That's our Pythagorean theorem. So a squared plus 9 squared equals 11 squared. That gives us a squared plus 81 equals 121. Subtract 81 from both sides. We get a squared is equal to 40. Now I'm going to take the square root of both sides and get a is equal to the square root of 40. If you want to simplify it, that's like 4 times 10, which is equal to 2 radical 10, because when we take the square root of 4, we get 2. Okay, so big things on this, knowing the Pythagorean theorem and this distance formula. If you are unsure about your radical rules, I really would suggest looking through the book and going back and reviewing your radical rules. And that is all.